All right, all right, all right. Good evening to all the grade 12 students. Welcome back, welcome back. Welcome back to one more session of your last minute board exam preparation. Nothing to worry, students. Today we are almost closer to your board examination. If I have to count chemistry, 1 month more. Nothing. I am there. You are there. Your confidence is there. Everything will work. Let us start the series. Today I'm doing the day 5 series. As I said in the previous 1, 2, 3, and 4, I have done the solutions chapter. Yes, in solutions chapter, everything is covered. So please watch the series. There is a playlist which is kept as 2024 board preparation. In that, I have kept all the playlist and everything is kept in that. Board exam preparation for grade 12. This is kept in this. So today we are going to do one more important organic chapter. That's nothing but your HaloAlkanes and HaloArenes. As mentioned, students, I'll be doing same multiple choice questions, very short answer questions, and I'm also going to do long answer questions also. Question and answer, both I'm going to send students. Then assertion reasoning type, content based, analogy type, and important previous year's board papers. So everything will be covered in this series. So please stay connected and watch the video completely, because when I say multiple choice questions, this will be 100% like that. So you're going to watch the complete video and note it. So for watching the video, as I said, once again, I'm reminding for all the new students who are joining me for the first time, hello, namaskaram, vanakkam, shastri akal, adabirse, welcome, welcome, welcome. Chinnagidra also is there. So to all the new students who have joined, I have already done 1.7k videos for your grade 12th. Okay. So grade 12, grade 11th also is there, grade 10th also is there. So this 1.7k videos, whatever I have done is done from line by line NCRT. So I have already done from NCRT and I've kept it in the playlist. So please check it. That will cover your complete book, textbook. Next important thing, I've also sent handwritten notes, students. I've sent 9 chapters handwritten notes. So handwritten notes are according to the board pattern. So this because I being a part of the board correction, so I have given the handwritten notes according to the board pattern so that you can get full marks. Most important, last but not the least, as I said, I'll be uploading videos on daily basis. So your task is plan your schedule properly. Yes, most three important things. Good food is important, or healthy food is important. Healthy sleep or good sleep or healthy sleep, rather, whatever you say, healthy sleep is important. And apart from food and sleep, believing in yourself and staying calm is very important, students. Believe in yourself. If you believe in yourself and you stay calm, you know what happens? Automatically, your energy saves. Yes. So, nothing to worry. Relax. Just believe in yourself. Let's start and start working. Believing is not only thing. You should work hard for that. Let's start. So, there's a question given to us in the MCQ. This is the question number 1. Let's see the question. Which of the following is an achiral molecule? Oh, very, very important concept, achiral. So before we go into the concept, let us see the examples. 2-chlorobutane, 2-bromopentane, pentan, 2-ol, and chloroethane. So first of all, students, chiral and achiral concept, simple, known by heart, nothing, it's easy. Suppose if I say something is chiral carbon or chiral center, rather, chiral center means a carbon which is attached to 4 different groups, A, B, C, and D. This is easy. If I say achiral means a carbon which is not attached to all, means all the groups are not different. For example, carbon is here A, and this also may be A, and this is B, or this is B and this is C. So this carbon may be different, means the carbon 2 may be same. When 2 may be same, called they are called as achiral centers. So this is your asterisk. This is your chiral center, which will be showing 4 different atoms. Now, if it is chiral center, what it is? If it is chiral center, as I said, these are optically active in nature. They'll rotate the plane polarized light, optically active. They rotate the plane polarized light. So you can see the rotation part. That rotation, because of this active center, they show. Here there is no rotation because 2 centers are same. They are optically inactive in nature. This is what they can't rotate, optically inactive. So when they don't rotate, we will do not see any variation in the structure. Correct. Next important thing, the chiral carbons, the chiral centers are they form non-superimposable mirror images. Non-superimposable mirror images. Okay. Ma'am, what is this? Let me complete this and I'll tell you. And here they form superimposable mirror images. Superimposable. because they're not changing anything, right? Impossible. Everything is the same. For example, I take a mirror and I draw the structure here. C scar, this an asterisk. Asterisk represents your, what do you say, chiral center. This is a C and this is D. Now you see, I take this and superimpose. Will both be same? B will come under D. D will come under B. Correct? Huh? So that's why we said non-superimposable. In this case, because I said superimposable, they're optically inactive, they don't rotate any plane polarized light, so they're superimposable one below the other. If I take, there's no rotation, so one more molecule will come under this one, this one, and this one. So they're optically active and they are optically inactive. And chiral center, you should remember, no plane of symmetry, and they have plane of symmetry. So here they will not ask you about any plane of symmetry questions. Oh, line is very vague, but don't mind, concept is important. So here this is no plane of symmetry, so plane of symmetry is absent here, plane of symmetry is present here. Okay, let us take this concept and understand. Go back to the question. Which of the following is a chiral molecule? That means they're asking about this part, this part. Let us see. So whenever such question is given to you, take the compound and draw the structures. So here what did we draw? 2-chlorobutane. See here, 2-chlorobute means 4 carbon atoms, 1 2 3 4. So here, because achiral, as I said, they don't rotate, but I've just drawn the structure with the mirror images. So when I draw the mirror image of this both, just see, now I'm trying to superimpose one below the other. See here, I'm getting it here. When I get it here, what will happen? Chlorine is below here, H, C2H5 here, H is below Cl. Are they superimposable? They are non-superimposable. See here. So the first one is non-superimposable mirror images. First. Second thing is, ma'am, can I say this as chiral molecule? Yes, you can say chiral molecule, because as you have observed, all the groups here are different. All are different. That's why the first chlorobutane is a chiral compound. Chiral. Okay, ruled out. Next, 2-bromobutane as 2-bromopentane. Here I have drawn 2-bromopentane. I have given the mirror images. As you have seen, all the groups here, whatever are there, are different. When they are different, what can you say? This is also a chiral molecule. This is also a chiral center, which is non-superimposable. Third one is pentan to all. Yes, pentan to all structure I have drawn here. Now you observe this carbon has, this is CH2, this is CH3. Now you see this carbon has one CH2, one OH, one H, and one CH3. Now tell me, is this also chiral? Yes, all the groups are different. This is also chiral center. Okay, the last one left out. Chloroethane. Now let us draw chloroethane. So all chirals are over. I should show which is a chiral. So chloroethane, one carbon, one more hydrogen, and 1, 2, 3, 4. Okay, the line. Okay, hydrogen. This is little bit wet structure, CH3, and this is chlorine. This is chloroethane. Now let me draw the mirror image of this. When I draw the mirror image of this carbon is here, this hydrogen is here, the CH3 again is, okay, this little bit this side because you are rotating it, CH3, okay, then will it rotate? Will rotate the plane polarized light? Nah. So that's one. Now you only check all the groups, or any group different? No, these and this groups are same. This and this group is same. Atom is same. That's why this two groups are same. Hence, this is the achiral molecule. Achiral. When the groups are same, it is achiral. So the correct option is option D. Achiral is a achiral molecule is option D. Easy. That's how you have to check. Next question. Let's see. Okay, can we conclude once again, because I'm left with one page. I'll conclude. So for chiral centers, you have to check what, students? All atoms, all four atoms to be different. What else should you see? They form mirror images. Okay, but these mirror images are superimposable? No, they are non-superimposable. Non-superimposable. Okay. In case of achiral centers, what will happen? In case of achiral centers, all four atoms are not same, are not different. All four atoms are not different, means two will be either same. Next, these form Mirror images, these form mirror images, but important thing is achiral molecules are superimposable on their mirror images. Superimposable on their mirror images. This is the concept. Easy? Easy. Now let's go to the next question. Important. When two halogen atoms are attached to the adjacent carbon atom, then they are called, okay, two halogen systems, they are attached to adjacent carbon, means two adjacent, one beside the other. Now let us see vicinal halide. What is vicinal halide? Okay, carbon, two halogen atoms, the valency 1, 2, 3, 4. 1, 2, 3, 4. Okay, this is A. Geminal dihalide. Geminal means halogen atom is attached to the same carbon. This is your geminal. Okay, did I have next page? I have next page. Why can't I use that next page? Okay, sorry. How many pages did I leave? One, two. Okay, only one page I have. Okay, then C, vinylic halide. Okay, let me draw vinylic. Then, okay, this is your double bond. This is X. And what is the specialty of this? This is sp2 hybridized. Third one or the fourth one is allylic halide. Okay, let me take this double bond and this is X. Okay, then now what happened here? This one is, okay, done. Now let us understand. In case 1, the halogen atom or the given halogen atom is attached to adjacent carbon atoms. This is 1 and this is 2. That is what they asked me. Yes, adjacent carbon atoms means they are attached to two different carbon atoms. This is vicinal dihalide. Perfect. Geminal means halogen atom is attached to the same carbon. Vinylic means halogen is attached to a carbon which is having double bond. That is nothing but double bond is nothing but sp2 hybridized carbon. This is called vinylic. Allylic means you have a halogen attached to a carbon which is means it is not directly attached to the double bond. There is in between, there is a bond here. There's a bond here. So this is called allylic. Easy, easy. So let us conclude one, students. Vicinal means adjacent carbon atoms. Halogen is attached to halogen X is attached to adjacent carbon atom. Geminal means halogen is attached to same carbon atom. If it is vinylic, what is it? Halogen is attached to sp2 hybridized carbon atom. Hybridized carbon atom. Allylic means what? Allylic is attached to carbon atom, means not directly attached to sp2, but there is a carbon atom which is to which it is attached. Easy? Easy. Next question. CH3, CH2. Okay, here they're giving me Grignard's reagent. What did they say? They have taken one here, HaloAlkane. They have taken magnesium. And further on hydrolysis, it's giving me a product. They're asking me identify X and identify Y. They've given 4 options A, B, C, D. Let us take all the options and do it. First of all, let us solve the question. So first of all, let me note the question. What did they give me? They have given me CH3, CH2, CH2I. Did I write it right? Yes, I have written. Yes, propyl iodide. To this, they have added magnesium. What is happening? This is nothing but Grignard's reagent, metal, organometallic compound, right? So it's completely going to add to this. CH3, CH2, CH2, MgI. Am I done? Done. Now, this is what X. What is this? What is this? This is nothing but Grignard's reagent. Do I have an option here? Yes, there is X value Grignard's reagent in this. I can mark it now only, easy, because here X is something alkane, here it is haloalkane, here it is alkane. So Grignard's reagent. Okay. Then what did they do? They have done hydrolysis to this. So when you do hydrolysis to this, as we said, the molecule, this particular HOH, completely the bond breaks and hydrogen goes to this carbon and forming an alkane. This is an alkane. What is left out? They have given magnesium hydroxide already. This is Y. Y. So what is the compound, students? What is the compound? Here Y is an alkene. Let us go back here. X is an Grignard's reagent. Let us go back and see. Yes, X is an Grignard's reagent. Y is an alkane. So option A is the correct one in this case. Correct, na? Option A is the correct one. Perfect. Done. Let us see the next question. The decreasing order of densities of alkyl halogen Density is itself. Okay, I know only one thing. Density is equal to mass by volume. And I also know density is directly related to mass. Correct? Na? Density is directly related to mass. Now, you see the structures. Seeing the number of carbon atoms only, I can check the mass, right? Seeing carbon atoms only, the weight of the carbon atoms only, I can check. So, normally when I take, see here, your first methyl chloride, the molecular weight is 48.5 grams. This is first one. And then what is the next one? Ethyl chloride. After methyl, they have given me ethyl. How much is this? This is 64.5 gram per mole. Okay, gram per mole, gram per mole. Third one is butyl chloride. It is nothing but 92.5 gram per mole. Okay. The fourth one which I got is propyl. That's nothing but 78.5 gram per mole. Now you only tell me, as I said, density is directly related to mass. Now they asked me to arrange what? They asked me to arrange in the decreasing orders. Decreasing orders means what, students? The one which is the less one no. So decreasing order means the highest one should be at the first and the least one should be there at the last. Okay, what is decreasing order? The highest one should be in the beginning and the least one should be at the last. What is the highest one? 3 is the highest. After that, 4 is the highest. After that, 2 is the highest. After that, 1 is the highest. Correct? 3, 4, 2 and 1. So highest is there at the beginning and least is there. So that's nothing but the decreasing order. Go back and mark the option. Which option is this? 3, 4, 2, 1. Na? 3, 4, 2, 1. Yes, this is the correct option. So what is the option, students? It is option D. Easy? Easy. Let's go to the next question. Easy, very easy question. CX bond is stronger in O. So when somebody is talking about the nature of bond, no, only one logic you remember. Yes, first logic. The logic is, yes, more electronegativity of halogen of X, bond length will be shorter because it will drag the electron density. When the bond length is shorter, what will happen to the CX bond? CX bond is strong or weak? CX bond is very, very strong, very strong. Correct? Now, this is the rule. Yes. Now you only tell me with this logic. Now tell me among all fluorine, iodine, bromine, chlorine, which was having more electronegativity? CF. This bond is strongest because more electron. Fluorine has 4 electronegativity. Correct. Which is the weakest bond? CI. Because the bond electronegativity is less, bond length also is more. So this is weaker bond. So the concept here is nothing. I have to remember in the exam. If CX bond is given, this if they talk anything about CX bond, concept number 1, electronegativity, high electronegativity. Concept number 2, short bond length. Short bond length. Concept number 3, tell me, smaller halogen atom. Smaller halogen atom. This is what is the concept. If you remember this, automatically the CX bond, that will be, if all these are there, what are the consequence of this? The CX bond is strong. This is what you have to remember. Easy? Easy. Next question. When benzene diazonium chloride is treated with cuprous chloride in HCl, chlorobenzene is formed. And what is this reaction? Okay, they have given different reactions. First of all, ITARD means what? We'll see. What is this? So ITARD reaction basically is going to convert, yeah, toluene in the presence of chromyl chloride and HCl to give me what, students? C6H5COCl plus CrCl3 plus water. Let me balance the reaction. Now, okay, this is 3, this is 3, this is also 3, and water, yeah, this is 8. Perfect. This is ITARD reaction. So anything related, benzene dichrome not there. Let us see Sandmeyer's reaction. Next is Sandmeyer's. So Sandmeyer's is easy for everybody. It's quite common reaction. Sandmeyer's is what? Here In San-Mies reaction, you're going to take BDC, right? Yes, BDC. That BDC is taken. Then you're treating with CuCl. You're also treating with HCl. What do you get? You're going to get C6H5Cl plus nitrogen gas plus CuCl2 plus HCl. And now, is this option correct? Yes, let us see the question. When BDC is treated with cuprous chloride and HCl. Oh yeah, this is BDC. Whenever you see BDC in the reaction, immediately mark Sandmeyer's. Okay. Now Gattermann's reaction also, let us write so that it is a revision for you all students. So Gattermann's reaction, Gattermann's is nothing but your, okay, Cu plus HCl you're taking, and in the presence of AlCl3 you're preparing and aldehyde. What is Perkins reaction, students? You don't have for your grade 12th, but Perkins reaction is there for state board students. So I'm trying to give this Perkins reaction. This is your Perkins reaction in the presence of acid catalyst, and you're getting an acid. This is your acid. Okay, done. So these are the four reactions, but my correct option whenever I see BDC, option B is the correct option. Done. Let's see. Next question. Aryl halides do not undergo nucleophilic substitution reactions under normal ordinary conditions. So aryl halide. Aryl halide. What are you seeing this aryl halide? They're given 1, 2, 3, 4 options, and below that they've given the choices. Let's see. They do not go NSR. NSR means nothing, students. Reaction with your PCl3 nucleophiles, PCl5, SOCl2. All these are there, no? Yes. All those nucleophilic. Why it is not undergoing? Now, as you see, in aryl halides, what are you observing? They are pi bonds, alternate pi bonds. Automatically, when you're seeing alternate pi bonds, it is going to show resonating structures. Finally, you're getting a resonance stable compound. Perfect, very important. Now, if it is resonating, are the electrons readily available? Is it easy for it to form the bond? No. Difficult, right? That's why there is no substitution possible because it is resonance stabilized. So again, aryl halides do not undergo nucleophilic substitution reactions because, let us approach of nucleophile is restarted wrong. Carbon carrying halogen atom is sp3 hybridized. Carbon carrying halogen atom is sp3 hybridized. Okay, this is right, correct na? Here it's attached to a carbon with sp3 hybridized. Okay, the substrate molecule is destabilized due to resonance. The substrate molecule is destabilized by resonance. Okay, this is also right. Partial double bond character between carbon and halogen, that's not the reason, because resonance is the main concept. Correct now, resonance is the main concept. Okay, now let us see which one. Option A, 2 and 4, no, ruled out. Option B, 2 and 3, correct. This is all wrong. This is also wrong. This is also wrong. So here the correct answer is option B. Done. Let's check. Now, before we go, what should I do? I have to summarize that. So, aryl halides are resonance stabilized. Because aryl halides are resonance stabilized, they do not participate in NSR reactions. That's it. Next question. Para-dichlorobenzene has higher melting point than ortho and meta. Why? Simple reason. They have given different options. Whenever somebody is talking about melting point, remember only one thing. Just check for a concept of symmetrical structures. Check for symmetrical structure, and also talk in terms of crystalline structures. Symmetrical and crystalline structures. Now, see the options. Para-dichlorobenzene is more polar than ortho and meta. That's not the reason. They have given the same thing again. Yes, para-isomer has a symmetrical crystalline structure. Perfect. Because of this, it fits into the lattice one after the other. The para-isomer fits into the lattice so that it's very difficult for us to break the bond. The lattice is like this. Okay, so that's why. So boiling point, that's not the concept of melting. All these are correct. So here, what is the correct option, students? The correct option is option B. So when somebody is asking you about melting point, what should you see? You have to see the symmetry. Symmetry should be there. Symmetrical. and you should have a crystalline structure. Okay, crystalline structure, symmetrical structure, and crystalline structure is what is important for high MP. High MP. Okay, next question. Aryl halides cannot be prepared by the reaction of aryl alcohols with PCl3, PCl5, SOCl2. What is the reason? Aryl halides cannot be prepared. Oh, same thing. The nucleophilic substitution reactions. They're asking why it is not possible for that to prepare. Okay. First of all, aryl halides. Do I have place? Okay. And do I? Yes, I have place. Okay. Done. Done. I have place. So now remember. First of all, aryl halides. One concept only I should remember. What is that? Aryl halides are resonance stabilized. Correct, na? So let us rule out one. Phenols are highly stable compound. Okay. Phenol, carbon oxygen bond is phenol. Has a partial double bond character. Okay. Carbon oxygen bond is highly polar. All of this. Okay. Simple. As I said, aryl halides are resonance stabilized. So where is resonance observed in this part? Partial double bond character is nothing but resonance, na? Because during resonance, the shift of pi bonds and finally this carbon gets the partial double bond character. That is what we have seen here also. See here, just now I've shown you, see here. Correct, na? Here this is getting the partial double bond character. So simple reason, students. So because of this partial double bond character, what will happen? Phenol, let us take phenol. Phenol is having partial double bond. Okay. This partial, because of this partial double bond, what is observed? Resonance is observed. Correct. When resonance is observed, what will become stronger? Yes, because of resonance, what will become stronger, students? Because of resonance, your C carbon oxygen bond, this bond becomes stronger. Bond becomes stronger. Correct, na? When this bond becomes stronger, what will happen? Reactivity decreases. Reactivity towards NSR decreases. Towards NSR decreases. When it decreases, automatically there's no participation, no? Right? So NSR is nothing but conversion of alcohols to halides. Correct, na? Halides or rather haloalkanes. Haloalkanes. Correct, na? Yes. Now go back to the option and see. Aryl halides cannot be prepared by the reaction of aryl alcohols with PCl3, PCl5. What is the concept? Concept is option B. So the correct answer you have to check is or double bond or resonance or anything. Okay. Next question. HaloArenes is less reactive than nucleophilic substitution reaction. Halo, same concept, students. Whenever somebody is asking less reactive to NSR means resonance effect. Set resonance effect. All right. Now, students, remember, as I said, I'm going to give you line by line MCQ. So after this questions, line by line MCQ is going to start. Line by line MCQ, and this MCQ is going to cover starting from your classification till your last topic, to the last topic on the polyhalogen compounds till the last haloarenes. Everything it covers. So please watch the complete video. As I said, please like the video, please share the video, and I request you to please show your support to WC. Your support means a lot to me, students. Okay, I'll be joining again one more video with all the MCQs. All right.